In the previous video highlighting the 140 amp alternator, I showed how the 110 amp alternator performs. With any alternator, through engine start, everything is the same. The red line glow plugs take a deep current draw. The light blue battery line has a deeper output due to the electronics. 400 amps of starter demand lowered the voltage down even more, but the glow plugs reduce their draw as they warm. The 110 amp alternator only provides 60 amps at idle, so the light blue line shows the batteries are still being discharged to make up for the rest. The voltage is limited due to the lack of amps out of the alternator. Once the glow plugs are off, the batteries are taking in all they can. Voltage is still suppressed due to the 60 amp alternator output. The 140 amp alternator does better with about 80 amps output at cold idle. The 20 amps additional output takes less out of the batteries, the light blue line. Once the glow plugs are off, the voltage rises to the limit of 14.4 volts. Since the batteries were not depleted as much, they immediately start to absorb less, shown by the downslope of the light blue line. If you install a smaller diameter pulley on the 140 to overdrive it, the idle current increases to about 125 amps. This doubling of the 110 amp alternator output does not require the batteries to augment the demand, so they accept a charge. As the batteries fill, the headroom, or increased differential of available current over current demand, slowly allows the voltage to increase. Once the glow plugs are off, the batteries are absorbing much less, and that permits the voltage to reach the 14.4 volt target. The next alternator I used on my truck is the LN 230 amp unit. It has a larger case that bolts directly in place of the OE alternators with the supplied longer bolts. It also has the weight that tells of its larger copper windings around the larger steel core. The alternator conforms to the factory harness connector on the Powerstroke 6.0, so it's plug and play. The LN has an 8mm positive post, while the 110 and 140 alternators have a 6mm post. So the factory cable eyelet needs to be enlarged. Be warned, a power drill will tear this eyelet out of your hand if you're holding it with your fingers. The rear of the case also has a grounding bolt, if you want to use a grounded cable. It's not easy to get to, but more professional than using one of the mounting bolts. It's easier to put it on the alternator before you mount it. With a stock diameter pulley, the original drive belt just fits over the lip if you bring the tensioner to its full limit. Prestolite's LN division designs this alternator for commercial applications. Previously, it was a USA-based company with a long history of supplying commercial starters and alternators. Like many other companies, it's now owned by a Chinese group. So far, it's been mostly USA-based. I've known of Prestolite from my decades of working with Class 8 tractor-trailers and transit buses, where it has a solid reputation. This particular design covers a lot of the 6.0-liter applications. One of the design upgrades for the 6.0 was the glow plug control module to avoid excessive heating of the glow plugs. There are two pathways from the glow plug control module to the powertrain control module. Most of us understand the glow plug timing is adjusted from 1 to 120 seconds. It's typically known the engine oil temperature and the altitude or air density determines this. It's also controlled by system voltage. The glow plug control module has a voltage set point so the glow plugs do not overheat and burn off the tips, which can happen with the 7.3 motors using a primitive glow plug relay. I think this alternator has excellent performance once we get past the glow plug operation, but it can concern some owners with its interface with the 6.0's glow plug control module. during the first minute or so of running. This on-off action is most often noticed with the headlights changing their brightness. From the graph, you can see the glow plug activity by the red line. The LN literature says it was designed for the 6.0 and that its top voltage is 14.4 volts. That's wrong based on my own experience and that of others. When I asked Prestolite's technical staff, they had no clue there was a GPCM on the 6-liter. Or of this limitation. So I'm going to spend more time than I usually would showing this situation. The rest of the alternator's operation is boring, just a good supply of electricity. But for those who don't understand what's happening, it can be worrisome, or just annoying. As you can see from the light blue line on the graph, the batteries are recharging right out the door. Here's one of my side experiments. It's again with the stock pulley. I have 10.59 volts at starter engagement at the battery's maximum depth of discharge. 180 amps output. A slow voltage rise. It took 30 seconds before the glow plugs kicked out. In this situation, it took some time for the voltage to climb and the glow plugs kick off. And stayed off. By the light blue battery line, look how much current these batteries were absorbing. These batteries were fully charged overnight to 12.7 volts by the use of a battery maintainer. What I used this time were battery warmers on this below freezing night. Battery capacity is influenced by temperature. When it's cold, the battery capacity is diminished. The voltage is reduced, and the resistance to flow is increased, both when giving out and accepting electricity. Being warm, the batteries had less resistance. The voltage drop during wait to start was less, and during starter engagement. The batteries accepted current back in at a higher rate, even with the glow plugs on. This alternator was able to oblige. For this test, I depleted the batteries, and the voltage for these batteries show they're about 80% charged. We have a depth of discharge to about 10.08 volts at starter engagement. No alternator has influence here. It's all battery. But the glow plugs kick off early, and the motor is a little cranky on combustion. Voltage output settles close to 14.6 volt and is stable. Look at the light blue battery line. Cold batteries have a lower exchange rate. That's both giving out electricity as well as recharging. Even though a discharged state with these batteries, the voltage kicked up faster and just shut down the glow plugs. Because the batteries were limited with their acceptance rate, the current demand was lower. The voltage was high and kept the glow plugs off. So I looked at two variables during this comparison just a few days apart. The left trial was with the cold depleted batteries at 80%. The right warm fully charged batteries on a cold night. But since a higher amount of current went into the warmer batteries, the headroom was less and the voltage increase was delayed. And the tug-of-war between the voltage regulator and the glow plugs was tempered. It also did not occur with the colder battery situation. There's no easy answer here. But a damn good voltage supply for the FICM if that's your concern. And maybe more than that. It takes many hours to recharge a battery to its fullest capacity. For the majority of this work, I used a trickle charger overnight, then burned off the float charge a few hours before any of this recording. That's why you often see 12.6 to 12.7 volts initially. We never fully recharge under normal driving, one of the causes of shorter battery life. If you are doing short drives during the winter, every minute of charging counts. This situation of battery warmers and a high-output alternator may help that situation. And this out-of-spec voltage regulator may be more in line with AGM batteries. But one should check with their battery manufacturer to see if that's correct for their battery choice. So what would happen with a smaller pulley that increased the RPM of the alternator? With a small pulley, the amps step over 200, and the voltage kicked right up and the glow plug stayed off early. The EPA may not be happy, but the truck was. One minute out, 35 amps. 10 minutes out. This alternator is outputting about 19 amps. And it's heating up to 86 degrees Fahrenheit, both the case and the windings. The hood is up, so temperature is dependent on the alternator. No extra cooling from the removed stator or air deflector. I'm going mobile. The engine electronics is using 15.8 amps, so each battery at this point is absorbing 1.5 amps, as they should. I'll show the difference in current the FICM uses to drive cold injector spools. It's about 7 amps more than warm injectors. I'll sidetrack again. After a 45-minute drive in the late summer, I wanted to check the alternator output without any devices on. The batteries are full, and the alternator is not hotter than anything else under the hood. The same batteries, fully charged, the same small pulley, and a warm 74-degree early summer day. So the voltage regulator and the glow plug control module are not getting along. the small pulley is not the cure for all situations, and neither is the stock pulley. Battery temperature, depletion, their age are all factors in the battery's resistance and recharging needs. All that, along with the motor's idle speed, affects the issue. I focused on the conflict with the glow plugs during the first few minutes, as people don't understand what's going on. The easiest way around the issue is to give the alternator more to do, add more of a load. And I usually have the fan on, and typically never have an issue. Two-gauge wire. Once the 1 to 2 minutes are up, it's an excellent alternator that provides a lot of consistent power. Even after an hour drive, and it does so running cool. But any alternator in the 200 amp output range should provide this capability, probably without the tug of war, since others would have an in-spec voltage set point from a different voltage regulator. And maybe a replacement aftermarket voltage regulator is all it would take to relieve this. If you are interested in this alternator, be aware it has been copied out of China. They are on eBay, and I'd guess despite the difference in price, Prestolite manufactures neither. At Amazon, the two on the ends are typical price of the copied product. The middle one may be real, but I can't tell. WAI is a China-based look-alike manufacturer. These are pictures of my box and my alternator. If it's not in a Leece-Neville box, or without a label, or doesn't include longer bolts, there's a good chance it's a copy. From my experience, there are 3 sources often discussed for this alternator. The first is Fickham Repair, and this alternator is described as their best value. It comes with a 1-year warranty, and they discuss the need to fasten the pulley to the shaft properly. They offer to install an overdrive pulley, and they sell an extensive cable kit, so out the door with shipping would be $585 to me. Nation's Starter and Alternators has also been mentioned. They have produced a video of how to tell the difference between a real LN and a copy, but in the past they have been a source that has sold a copied alternator. Y2K on Ford Truck Enthusiasts has an account of discussing the situation with them. He is a person who investigates things very well. I've known him for 18 years. In Nation's video, they say they now only sell the LN alternator, but ship without a box and take off the Prestolite label. It's not how I would buy one. If you're interested, I suggest talking to them directly. Offering a 2-year warranty, they include a stock-size pulley and sell a power cable option. In the video, they warn of belt slippage with a smaller pulley, something none of the dozen online people I know that have used the small pulley have complained about. With free shipping, I hope they are selling the real alternator, but I want an LN box and the label on the alternator. XDP is close to home, and I've been to their store. They sell the real one. Y2K also has talked to them, as discussed in the noted thread. As an authorized dealer, it's at an attractive price combining with the Diesel 10 discount code, and at that price level, their shipping is free. There's no pulley options or cables, so it's DIY hunting and gathering. Not that doing that is hard. This company on eBay sells both a smaller diameter pulley and a stock size for a reasonable price. So do other vendors. Compare any pulley with these dimensions, or you can reuse the pulley from your existing alternator. At the price of this alternator, a nice new pulley would look good. This aftermarket stock size pulley, a little help getting the belt over this alternator that sits higher. The smaller diameter pulley makes getting the belt on like the factory height alternator. To attach the pulley to the specified torque value, you have to get creative. I used an impact socket with a hole on the side and a screw to grip with vice grips. You need a hex socket, and you need a torque wrench capable of reading in the counterclockwise direction. Beam torque wrenches work even after you've owned it for 51 years. Cabling for this needs another video, as this one is getting long. Thanks for watching.